Hi and welcome again to the Code Me When channel. My name is Gabor Sabo, and in this video I am with Oz Mendelsohn. He was one of my students at Weizmann Institution in the programming bootcamp, and now we are going to discuss his project, his final project. So, hi Oz,
Uh,
please introduce yourself.
Hi Gabor. So as Gabor said, I'm Oz Mendelsohn. I'm in my second years of the master's degree in the Weizmann Institute of Science. I'm in Leo Kornick group. Under his supervision is the computational quantum chemistry group. We do mainly computational calculation with mainly DFT. And here I'm going to present my project. So the ideal concept behind the project is that we are using a cluster to run our calculation, which need a high number of cores and computers to run it. So we are using our Faculty of Chemistry high performance computer to run these jobs. Because it's a shared resources, there is a job manager system called PBS, which manage all all the jobs, and we need to interact with this system. So I written a project, a model list of function to help me to interact with this job system more fluently and automatically.
I
So
think if I remember that this is partially an open source system, right? Or it's
it's the as far as I understand, we are running the version of the professional PBS system, but
mhm.
it's based on the open source. There is a GitHub repository for that, and it's a very popular job system manager in all kind of high performance computer system clusters. I encouraged it in university in the USA, in George Mason University. Also, I know that the USA Army cluster using these systems. Also, the Technion Institute of Science using this
Mhm.
job manager system. It's a very popular, mainly because it's open source, and pretty much every cluster administrator can use it. And as far as I heard, it's one of the best. It does not have like
Yeah.
many problem.
Yeah, I was just searching for the name, and it's called PBS, the open source version at least. I guess we'll put it under the video so people can
Yeah,
be able to access it if you're interested.
yeah, and I don't. I try to look it maybe to try and like kind of to install it on a virtual machine. It's not something simple to install.
Okay.
Yeah. That also there is like very end documentation. That's why one of the reason that I want to create like a script that will help me to negate the need for documentation in some way.
Okay.
So maybe I'll share my screen here. So maybe there's a quick background. There is a website of the cluster. In the Weizmann Institute, we have a giant cluster in our Faculty of Chemistry. There is more than 7,000 cores. Each one of the cores are, of course, not on a single CPU. They are spread across several CPUs. There are CPUs with 16 cores, and there are CPUs with 40 cores. And each one of the CPU is located in a single machine, which we call a node. So that's kind of information to know. There is each node have its own memory. Of course, the 88 terabytes of RAM memory, it's not in a single machine. It's
Yeah.
across each one of the machine. So that's like, as you can see, it's of course it's high power computing system, but it's distributed.
Hmm.
So how does it look like? I think here it will be better that I just reopen it and go to our folder and enlarge the text.
Okay. We are just still seeing the. Okay. Now it's good.
Yeah,
Okay.
and so how exactly it's look like? That's the terminal. That's the login node. Here I'm connecting.
Wait
Here
a
we
second.
can
I'm seeing the web page.
only still the web page.
Yeah, for a second I saw something else, but
I think of here.
yeah. Okay, now it's good.
That's the terminal. Yeah, so
Okay.
that's the terminal. That's how we connect into the to the cluster. It's running Linux, and that's pretty much what we see. Here you can see there is a large notice that this is only the login node. Here we would not run our calculation. From here we are interfacing with the job manager system. So how does it look like? We have our series of function of method that we are using. QStat is the list of jobs that running in the cluster. I will only show mine. -u my username, and here you can see my own jobs. You can see the list of them, and I have a function that even elaborate even more. Here you can see on what type of nodes I'm running. I'm running on one node called CFL 122, another node called CFL 124, and etc. There is jobs that are still in the queue, which not running on a specific node, and there is jobs that are running, and I have them run on a specific node.
So wait a second. Those that are not at a specific node, they're not running right now. They're waiting. That's what.
Yeah, they're running. Yeah, Q is Q
Okay.
meaning the Q queue, and R mean running.
Okay.
Yeah. So
Oh, I see it now. Okay.
yeah, so that's that list of jobs.
So in this S column, almost at the end, there is the R and the Q. Okay, I see.
Yeah, S column. Yeah, it's kind of hard to see.
Okay.
And pretty much you have access to all the information of all the jobs. Here it's a text file that I black out the job name and the username of all kind of job. Here you have the status. There is like more than 3,000 jobs.
Later, after the video, you explain me how did you black it out. Okay.
Yeah. So here just go in until the titles of the columns, then it will be clearer. As you can see, there's a lot of job running here. So we have the job ID, the username. Here I haven't blacked out my jobs with my username.
It's a text file. Okay. Oh, I saw
Yeah,
it's a comment.
yeah, it's just a text file. Yeah. It's just a text file that I rewrite beforehand. We have the all kind of jobs that are running. Here there is the queue, the name of the queue. That's another information. There is like several queue with different priorities. The long one with the lowest priority. You can run very, very long jobs. There is another one, the idle queue, which is a queue that is specific for jobs that are for resources that nobody use. So you can go and use all kind of resources. There is also a medium queue. There is also a short one. Nobody nobody run right now in short because it's a very, very short one. It's mainly for debugging. Medium, and there is people that are running in medium queue. So it's.
By the way, I see that many people do this, but I don't know really why. But you could also just write grep medium and the name of the file, and that would do the same. So
yeah, because I'm barely using the cat command. It just yeah.
And also when you show the top few lines, you could just type in head and the name of the file, and it would show the first few lines.
Okay.
So, but I see many people do this, that cat something, and then they do, let's say, head or grep or whatever. And I'm not really sure why they need. Maybe that's how they were taught, and they so just got used to it. But you don't really need to cat first and then grep through it.
Okay.
Just saying something.
Yeah. Yeah.
I'm also in teaching mode as usual.
Yeah. Yeah. So, how exactly you interacting with this submission line? You need to submit a file with the resource that you ask and the command line that you want to run.
Okay, just one second. The file you showed me earlier is basically the output of is a listing of all the nodes, or right?
The file that I print out is just the status of all the jobs in the cluster right now.
Okay, and
I
it
just
was the result of some command that you saved in a file.
yeah, it's just a simple command of qstat without nothing, but it's going to
Okay.
print other people's job, and I will try to avoid it.
Okay, yeah, okay, now I understand.
Yeah.
Okay, so
So
the
this is
file
why
was
that's why I prepared a file with just
okay. Good,
yeah
good,
yeah.
great.
So that's a
Privacy
submission.
is important.
Yeah, just like to avoid to step on anyone's toes, even by accident.
Yeah, sure.
So that's the submission file. Here we have like two main parts, which is the how we talk with the schedule, with the job manager system, with the in this part, and the second part is it's an actual Bash interface. It's just kind of a Bash script. So if we go over the first part, first of all, we need to give a name for the job. Here I added the lovely name of Naming McNameface.
So wait a second. This is a .pbs file. So this is itself not a Bash script, but it can also be executed as a Bash script. And that's why the first commands basically that go to the PBS are commands. So because these are not shell commands. These are
yeah, exactly. They are for the PBS.
Yeah. Okay.
That's why the weird comment way. So
Yeah.
it's the argument for the PBS system. So here there is the name for the job. It's like not limited for the same name for several jobs, or it's whatever you want to give it a name, just so you can find it easily in the qstat and have knowledge about the job. Here it's probably the most important line is what exactly resources you're going to ask for your job. So the resource goes slowly in each category. The select argument is for the numbers of nodes, the number of computers that you're going to ask. Like if you're going to ask 2, it's going to multiply all of that by 2.
Okay.
So that's here you need to select how many computers you want to ask, how many nodes you want to ask. And CPUs is the number of CPU for each one of the nodes that you're asking, for each one of the select that you ask. It's have to be up to a number of the CPU in a single node. If you're going to ask for a node with 16 CPUs, you need to ask up to 16. And if you're going to ask a node with 40, you can ask up to 40.
So you have explicitly say that you are asking for something big, and then like many cores, and then you say how many, or just by giving, let's say, 40 here, the system will already know that it needs the big ones.
Yeah, it's you if you're going to submit like a job that asks too many resources, it just do not going to run. That's what's going to happen. It will not enter to any machine because any machine can satisfy your resources request. The same way is for the memory.
How much memory you need?
Yeah, and that's the node type. There is like several, as I said, there is several different node types, which which are separated by the number of CPUs. There is the one with the 16. There's the one with the 40. Here I am asking the node with 36 nodes CPUs for each one and 180 gigabyte of RAM. Of course, because I'm asking a very low.
Why? So just sorry. Why are you asking for that when you're asking for So you actually ask only for 1 GB memory for your process and only
Yeah,
one CPU, but then you're saying that you want it to run on a big machine, right? That's basically what you're saying.
yeah, exactly. Just for example,
Okay.
yeah, it's just for example, just a way to keep this. I'm using very, very low resources because the cluster right now is cramped. So I'll try to sneak in more quickly. That's the thing.
Okay.
Yeah.
So you have to know what
Yeah, exactly.
how to get around with the jobs of other people. Okay.
Yeah, yeah. It's a thing to notice about. Of course, because it's shared resources, the PBS system take out a lot of load. But of course, you need to understand and know about what resources are available, what you can ask, and what are your own limitation.
Okay.
Here we're going to, in the next line is for the specific queue, what is the priority of your job. And another thing to say, inside this priority, there is also different limitation for how many resources you can ask. In the medium, which is a queue with a maximum time of 8 hours, you can ask relatively high number of resources. It's usually in inverse connection. Like if you want to run a job for a long time, you cannot ask for a lot of resources because in
Okay.
hope that we will not all of them at once.
And the whole time is the processing time.
Yeah, like after 8 hours, it's going to kill the job no matter what.
Okay.
Here, there is those two arguments are connected. It's just for sending emails during when the job is finished, when the job is gave an error or something like that. And the AE argument is for the email address for how many information is going to send. And the last argument is the wall time, which is a specific time. I can put it up to 8 hours. I can even put it 1 hour. I can put it 10 minutes. The idea is you have a job that's not supposed to take so long. You can put it in a low number. So if something go bad and it's froze or something like that, you can make sure that you're going to release those resources for other people and not going to hug it for any kind of for
Yeah.
error. Yeah, so
And
that's it.
also you get not notified early, so you can fix your code and run it again. If it's waits for 8 hours and only then you get notified that something is broken in your code and it's frozen, let's say,
Yeah,
then
of
yeah,
course.
okay.
So the next part is kind of a bash commands that are specific for our ChemFarm setup. The way that our ChemFarm was configured in order to get the location of the resources, you need to use the ulimit command. Here it's just a CD for your specific folder. It's just a keywords and it's specific for each cluster. So I'll not go over it. So here we have the actual command that I'm going to run because I'm using Anaconda. And the way that the PBS work while is loading himself in a different system in a different computer. Sometimes the .file bash profile does not load correctly that I need for the conda command. So I'm reloading it just to make sure. I kind of find it hard to find what is the rule for when it's loading and when it does not. So it doesn't err to reload it.
Okay.
And here I'm just loading the environment with all the package that I need. And here I have like and here the actual command, the Python, which just running a dummy script, which is just sleep and just print some simple output. And eventually I use the argument parser package for any kind of input for this script.
Okay.
And
Well, it's
here,
just a demo, something for to show it, right?
yeah, just a demo to show it. It's an argument that I give it, and after it just output to a log file. So that's our
and this log file will arrive to your home directory, or how do you get it back?
In the same directory that I'm going to submit the job.
Okay.
So I'm going to use a submission command, which is qsub. then take the actual file and enter. And then it's going to submit the job, and that's the job number. And if I'm going to do qstat and give the job number, I'm going to see it. And right now is waiting the queue, the name is what I've specified, and the job number is the same. And unfortunately, because the CamFront is kind of cramped, I think it's going to take some time until it's going to enter. And after it, it's going to output the log file and some kind of status files for the job, like kind of diagnostics, and it's going to output 2 more files. So just a thing to notice, because I try to take care of this output files in my script, in my job, in my functions. So if we'll go to my package that I created, I'll try.
That was sort of the background, right?
Yeah, that was sort of the background, like exactly what's going on. So here I wrote an example in the name dot equal main section. I think I'll go over quickly on the function that I created and then go on the example. So the function that I created for interacting with this with the PBS, it's would go by order. Is one of them is the unique name. It's just a function to give like a random name. I found a very interesting package which is called a pet name, which gives like a random names for pets, and that's why I'm giving a random name for the job, and just to avoid some kind of repetition. That's kind of a playground. Node list it's a function that gives me a pandas data frame with all the information about the current nodes.
Would you like to show that? So open these ones so we can take a look at them.
That's
no, but that was also interesting.
Yeah.
So this is just a really short thing.
It's just use generated. And you return a string. And the node list, it's based on. I'm going to write PBS nodes methods. It's AV, which going to give us a list of all the nodes and their status. Here we can see a specific node called CFJ 005. There is all kind of information. Here you can see that it's busy, and there is available memory, the memory, and the number of CPU, and all kind of information. So that command is based on another command that scraps this information. As I said, the command this function is scrapping is a command that was written by our cluster administrator. So I'll try to avoid to show it directly.
Okay.
So pretty much scrap is using by a pattern by using a regular expression and then create a data frame.
So you're parsing the output of this command.
Yeah, just of this comment, I'm parsing out, and then I have a data frame with all the information about each node, how many cores is at, how many cores are used in a single time, how many memories. I think it's supposed to be easy from PBS utils. Node lists here, and that's a data frame. There is the type of the node, the number of cores, how many cores are used, the memory. Just to give me information in a format that is easy to interact with Python, and it just returned a data frame.
Okay.
So job status, it just is returning is returning a data frame. Just take the qstat command, which gives me the information of all the jobs, and return it as a data frame form. I'm not going to run it because then I can get information about other people's jobs.
Okay.
But it just parsec the qstat command,
Mm-hmm.
the same one as you said, add qstat here. It's just going to parse this the command and give me all the information about the jobs, including what the most interesting is their status, which is run, and the job number.
Yeah.
And
Oh, and just now you just reminded me that this head command, and there's also a tail command. And what you have in pandas is basically coming from here, I guess.
yeah,
So
I won't be surprised. Yeah.
yeah, so you can deal with yeah.
Yeah.
So you can also give it how many lines. It has a default, but then you can give it a number of lines.
Okay. So that's the command that just creates the entire qstat information, the 1,000 of lines.
Mm-hmm.
And here there is a function that created the PBS file. What I showed, the submission file, it's created the file and then return back the path for the file, which
Okay.
include the full path and the name of the file. So you can use the qsubs function to submit it. If we'll go on the inputs, here you have the execute line. What's the line that is going to execute the final line? In our example that I show, it was just the conda activate and the Python line, run line.
Okay.
It's in the form of a string file, a string object. And here we have the PBS arguments that are coming in the form of a dict, or because I use the double asterisk, it can open up to a list of arguments. So the keywords, the path is the path for creating the file. I found it because there is in our cluster there is two main directory. One is the home folder, which is limited to 100 gigabyte of use, and there is another one with what's called the work, which is unlimited in the storage. So I'm usually working in the home directory and I create the files in the work directory. So that's an easy way to input this information. So I give in the path for a specific in the work directory. The name for the job, the name is going to give the job in the PBS keywords. Usually in this context, I like to use the unique name function to give it a special name for this job. Here I'm giving resources in the form of a dictionary, which is the same as I show in the submission file. There is the select option, the CPU options, the memory option.
Yeah, okay.
The node, and another thing that I didn't show, there is also the possibility to ask GPUs. That's for a very specific time. So the same for the world time, the queue, what exactly queue I'm asking, and the mail, and a log file, like if I want to give it a different log file to output this information. And it's creating the file and then give me back, it's creating an entire file in the machine and then just give me back the file of the path for the file. Just create a list. That's the part that I said it's specific for our cluster, and that's the executing line in the end to the log file, and just give me back its writing and just give me back the full name. So we'll minimize it. So here I have two methods that are kind of the same. Just after, because I started to use pandas, I changed it to one that can take pandas series. So what pretty much it's doing is taking the same argument as the PBS file, but also submit the job. So it just take the same arguments, but it's also submitting the file. It's used the qsub command, and then bring back the job ID If you notice that when I do use this qsub command, I go back
Yeah,
the
the number is the .pbs. Yeah.
yeah, exactly. So that's what I'm getting back. So that's kind of the same of the PBS creation, but only it's going to submit it and bring about the ID. Here it's the same idea, only for PBS series, which is connected to the next function that's going to create a data frame for all the job that I want to submit. So this function give a list of execution line, a list of PBS arguments for each one of the corresponding execution line, and possible input, optional input is the outcome parser for automatically adding to the execution line between the line and the log. So here it's just all three of them is in the format of a list, and each one of the elements in the list is the dictionary in the same format as the PBS file and the submission static job methods. And in the end is give me back a data frame organized with all the jobs and that I want to submit, each one with the corresponding resources and the arguments for the scripts. He just created and create eventually just a data frame dictionary. Here it's taking the data frame from the job data frame and go over all the jobs that have job ID, which mean that have been submitted and have been updated with a corresponding job ID, and check their status. Check their status if it's running or finished or still in the queue. So just keep information about the job and see what their status. You're given the job data frame and it's updated to the according information. You know how to check if a job is finished. The job is supposed to submit a .fin file, and if this file is present, you know the job has finished. Also, this way you can check if it's failed. Here is I think the mail method. It just is going to over all the data frame jobs and submit each row slowly, each one into the queue. So if we go quickly about the inputs, we have the data frame, which we have prepared using the job data frame function. The max queue option is the number of jobs that are still waiting in the queue before it's going to submit even more jobs. If this number of jobs is smaller from this number, it's going to submit more jobs to the queue. This way,
you have your own queue now.
Yeah, exactly. I'm just like create a different queue in order to avoid to spam like add a queue which is public. I created my own private queue, so in order to not spam the public queue.
And the queue is saved locally, or?
Yeah, it's saved locally. What I usually do, I'm running this script that uses this function on on a job that asks a single core in a single machine that run for a very, very long time. So I know it's like I'm barely using any resources, but I still not running on the login node. That's like kind of a trade-off. What you think is better, to run on the login nodes or running on a single CPU, but on one of the running nodes.
Yeah.
So the max time is the maximum time in hours that after it's going to end the loop, just to avoid something like just to avoid to write any kind of infinite loop. The wait time is the time in second that each time before it's going to update or check the number of files that are running or at a queue, just like kind of a time scale to how many how frequently it's going to check and try to resubmit, see if it's going to submit or and recheck. Another thing.
Before I forget, just one note here that maybe it would be better if it was max time underscore hours and wait time underscore seconds. All right, just like a first impression that I probably would get just confused. But
Yeah,
maybe it's too many words now. If you would also add that, so I'm not sure. I just thought about it.
no, it does not go over many times in the script, so maybe
No, I just think about it and
yeah, of course.
But it's sort of the thing is that for you who wrote this, it's probably obvious because you're already. But if you're giving it to someone else, maybe for them it's because they're seeing the first time or whatever. It's gonna be harder
Yeah,
to just.
yeah, probably will change it.
Okay.
Yeah, like
Sorry for interrupting.
in the beginning, everything was in second because I want everything to see that to reach the end time to see that everything is working. So that's the reason.
Yeah.
In the beginning, everything was 1 second and 1 second because I want to see that everything works.
Yes.
So that was the state of mind when I created the name file, the variable names.
Yeah.
Yeah.
There's also an option sometimes I see, but it requires more work that you can add to the number actually. So you don't type in 1000, but you take, let's say 1000H, and then internally but then these must be strings, and then internally you check what if the user gave you H or S and then or M.
Okay.
That's also an option, but it might be just too much work for not enough value.
Yeah, it's a possibility. So we'll go. Oh, the next input is the restart. I noticed that sometimes, for kind of random reason, some of the jobs can just crash without any particular reason. Maybe they're trying to access to the same file in the same time or something like that. So adding the option to restart job. So even though the job have failed, have run in the queue, finish running, have run, and then was removed from the queue. So this way, the job can in my internal my private queue in the data frame can go back to a mode of pending, like, and try to resubmit it again. And restart in the default value is 0, so not restart. You can change it to other value, maybe 3, 4. How many times is going to try to resubmit this file again? So there is you not just set restart until forever. Just like try 3 times. If 3 times, maybe there is something bad in the submission, in the execution line, maybe in the resource, something went bad in the line, and it's just going to fail. The dump option is just an option to during the submission process just to keep dumping the data frame file for the data frame, the pandas data frame to a specific file, maybe CSV, maybe JSON, that you can read and open and see like what is the status in kind of a readable way for a human. Like simply just go and use VI and read what is the status with of all the jobs, because there is a limit how much you can print in the output of the Python script. So that's what is going over, submitting. There is some kind of printing for the status of the job. That's kind of the longest function. Here, as I said, sometime in the end of each run, the jobs is outputting kind of a dump information. I think maybe we can see we can see here the dump information that the job are submitting in each. They're taking the job name and then give it some kind of information .e and then the job information. And it's happened for each job. Sometimes it contains valuable information. So here I created a function that we're going to see next, that when the job is finished, is going to move it to the same folder as the submission file that I have submitted. If it's in a different directory, it's very, very helpful to have the entire information of each run in a single folder. Here and here it's the breaking condition. If everything, there is nothing in the queue, nothing pending, nothing running, and nothing suspended, which is another option, then you can break the loop and exit the function. So this is the submission. Here is two short programs, which just the cleanup is just take the .e file, the .o file, the .fin file, which says if the job is finished, and the log file, and move it to the same folder as the submission file, the same one from the path PBS keywords. Here it's just the reset fail. It's taking the data frame and updated the status and check if the status was failed, if the job failed, and the number of reset is smaller than the fixed value that we have given. Then we are adding to the reset value. We know that to keep in check how many times the job has been restarted, and then it's moved to my private queue, which I stated as P for pending. That's it. And then he print out that is have restarted this job, just to keep notice that this job, maybe if we're going to see it restarting again, maybe there's something wrong.
Okay.
So that's the all the method that I wrote for this package. So here I tried kind of sophisticated. I don't try to use all the function in the same example. So here just a small setup, like a general setup. There is many kinds of nodes in our clusters. Some of them are for specific use case, like GPUs, or a lot of number of RAM, or any kind of even specific things, like there is specific nodes that have specific license for specific software, something like that. So there is some nodes which I'm not using and nobody in my group using. So that's the list of the node that I'm going to use. There is several more that I'm not going to use, but this is like usable nodes that I'm going to use. And the idea of this example that I'm going to loop all over the free nodes or the partially available nodes, and by using the node list function, I can create a submission file that's going to fill all the available space. So this way, by like 20 lines of code, which most of them are just excessive documentation, excessive comments, I can pretty much fill up all the available resources in the chem farm and using much more efficiently the chem farm because I have this Python interface and I could do this kind of automation. So here is just the list of usable nodes. That's the path that I want to run it, just in a temp folder because it's an example. Here I initialize my list for my arguments that I'm going to give to the function of create a job data frame. And here I'm using the node list, and I'm taking to get a data frame. And here I'm looping over all the lines with a status of free or status of partially free. And then I use the iterate words function to iterate over it. Okay. So here I'm just skipping the non-relevant nodes. If the node type is not in the list, it means it's a node type and I not want to even use it because it's have a different use case. And I just skip to the next line. Here, it's a very good practice to not overuse the RAM of the node, to use something like at max 90%. So that's like kind of this way to calculate, to use the available memory, and as long as it's not exceeding the 90% total memory of the nodes. And if it's going to exceed, if the max memory which I've defined as 90% exceeds the somebody using more than 90%, it means that this node is too crowded and it's going to skip it. And here there's another one, skip the crowded node and avoid to just use it because somebody already used all the RAM and it doesn't really matter how many CPUs are available.
Okay.
Here I'm checking how many CPUs are available. There is the total CPUs of each node and the CPUs that are being used currently. So just that minus that, give me the number of available CPUs. Maybe I'll open in the right side the node list, raw, and then give a better context about the names. So here the number of cores and the use core. In that case, because it's job busy, so I'm not going to even to iterate over CFA, but on this CFA. But if we're going to look on this one, this CFL, 40 minus 24 is 16, so I'm going to use 16 cores. And also there is almost half of the available memory, so I'm going to use something like 80 gigabyte of memory. So here I can run significant jobs, even though it's partially occupied. So so here I'm I'm set up the select number of node that I want to use. Because I'm tailor it for each node, I'm going to use only one node. I don't want to duplicate the same resources. I'm define the memory and the node type, which I tailor-made my request for each node type. So I'm asking the same one. And then I'm asking for a specific queue. The idle queue is queue that is specifically, that it can reach all the nodes and is specifically for any available resources. So it's the good practice to use this queue. Unfortunately, this queue is relatively slow because it checks all the available resources in the entire queue each time. For our use case, I'm just going to use like preset the same as I did in my submission file. I'm just overwrite the entire example with one node, one CPU, 1 gigabyte for specific
just for
node.
example,
This is why I add the debug comments and for the medium queue. And here we have the actual setup for the data frame. I'm giving a name. I'm using my unique name function. Just give me a random name. The executed line is just in a simple form of text. Because I'm using 2 lines, I'm adding the next line command. I'm running a dummy script. It's just going to run sleep for 1 second and then exit.
It might be better to use triple quotes, and then you can write multiple lines.
I know. Just it's kind of the way that PyCharm do it. Just using enter and is edits. Sometimes it is add plus and sometimes it add backslash. I not know the what is the.
What I mean is, instead of using these single quotes and then you \n, you could three.
The same as the documentation. I know. It's just there is in Python there is like 7 different way to do the same thing. Each thing there is 7 different way, and it's always a trade-off between readability and compact code. That's what I discovered about Python. So here I just transfer this variable to a dictionary for the right format for the function, and here I'm just giving in the form of a dictionary all the information that it needs for the PBS key arguments. Here I just edit in the parser key arguments. Here I just give like a random name. It just in this function from the pet name model just give me a random name of animal. That's it. That's it. And because there is a lot of there is almost 600 nodes, and there is a lot of them that are like partially free or free, and I not want to like now submit like tons of job. I'm using here another like If it's going to, if it's more than 10 job, just break the loop. It's also for debugging
Okay.
for our showcase. So here we are we are creating the job data frame, just giving the free list, and it's created by himself. And in here we just starting to submit it over time. So hopefully, I think that I made a small changes that. Yeah, I'll do it 1 second so it will be quicker. And also I'll make max q 3 each time, so it will be quicker. And it was, and just a sec, it's here. I'm not sure if you can see, it's uploading the file. Here it's, I'm going to check if it's uploading the same file. So here I'm just going to run it. Of course, ideally, I'm going to write the script. I'm going to run this script in a different job file, in a very long one. But because it's just an example and it's kind of not that heavy, I can run it on the login node. So just PBS utils, and because it's in name equal main, it's going to run this name. So that's our output. And here you can see it's submitted 3 lines. And initially, it's all of them are in the pending. Then he is telling me that he's running this full file. So I can like check it in a different terminal and see if this submission while is the same as I expected. It also gives me the job ID. And right now, there are all 3 of them in the queue. And it's going to loop it. Unfortunately, because the cluster right now is full, it may take some time. So we might need to wait a few seconds and then see it move to the running, and then it's run for a few seconds. And after it's going to run for just 1 second because I used the sleep command for 1 second. And then after it's finished, and then it move all the files back to the temp folder by itself, which I defined previously, and then move the job line to exit, to the exit column, and then I know that is finished like 3 jobs, 10 jobs, 7 jobs, or etc.
So on the right, what you see on the right hand side, it will update itself.
Yeah, exactly.
It just did. Okay, I'll just set it. It just did.
Yeah, it just did. Yeah, it's even was not, because I'm using wait time of 1 second. It was able to finish 3 job in the 1 second that is used to update itself. So as you can see, the queue, 3 jobs move from the pending to the queue. The 3 job move for a brief second to the running, and then move to exited, and then it's just looping, and that's the information. And that's it, just submitting. So of course, because this way, by doing this way, I can easily do like a simple Python loop of all of my parameter, and then submit like 100 jobs, and etc. So if we'll go and look inside, yeah, the problem is it's a very small font. Here we can see the output files.
Okay.
It's sometimes like only in the second loop going to move the files in the corresponding folder. So here we have the corresponding folder that is created. Here there is the submission file, and later is going to move all the information file to this folder. So I'm going to have everything in the same folder for any kind of looking back on the job, and make sure that everything works as it should. And of course, it's good practice for science and bookkeeping to keep all the things that you submitted and run it in a specific location that you know how to access.
Yeah,
So that's the package that I wrote. I think that the example pretty much show.
very impressive.
Yeah, thank you very much.
So just tell me, what was your background before the boot camp?
I have wrote in Python, but it was mainly like scripting. Like I never actually try to like write like a full function, like a model or something like. So,
Because it's very impressive.
so I know about data frame. Like I try I was after understanding the syntax of dot loc. If that's it, what you ask, the syntax of data frame dot loc is always very confusion because it's different from the symbol if statement in Python. Always find me confusion.
Okay.
Made me confused. Um,
Okay.
yeah. So here you can see three more job have ended. Uh,
So what will happen if now you stop this program or you get disconnected from the machine?
if I'm going to stop it, it's just stop it, and the jobs are the same. So there is not like they're running, but it's going to finish. It's going to output its file, and nobody going to scoop it and organize it. Unfortunately, like
Okay.
it's
So if you restart it, it won't continue monitoring them.
yeah. The notion of the dump file of the dumping for bookkeeping, I think like maybe to do some kind of restarting, but I do not. I think it's like if I'm going to create a file and then maybe tweak the submission again, and then it's going to rewrite the file. I think what is the best way to approach it, because I think there is a way that I can like accidentally resubmit all jobs if I not keep the name different each time.
Yeah.
So yeah, so how to approach it, I think. Uh,
Yeah, I guess I'll have to be like save everything in on the disk and then
yeah,
anytime you can just stop it and restart if needed because there is some database on a file in the
yeah,
file.
yeah. So here we're going just to look on the output file for one of the logs, just the random name .log, and we can see dummy script. That's the name of the file. That's a different name. Yeah, I forgot that I give it. Here there is also the pet name randomization name, and here's the three arguments that were given. And you
Yeah,
can see that here it's wait 1 second and then it's finished the dummy. So it seems that everything is working.
great. Well,
Yeah.
thank you very much.
Okay. So thank you very much.
It was very impressive. I'll have to tell you. Is this something that you can open source or you would like to open source or I don't know?
I have no problem to share it. I don't
Okay.
think like maybe like I think that the only thing that the node list is might be not useful for people outside the camp farm, but I
Yeah,
think
it's interesting how, yeah.
yeah,
But
but it's not mandatory. Like sometimes most of the time you need to exactly know exactly what kind of resource you're going to ask for, right? Because we're talking about the program that are running in very high in high number of nodes and chip CPUs, you need to make a right parameterization of the MPI. It's working on MPI, message processing interface, and you need to find it correctly for each situation. So it's also something that is sometimes specific, and there is like not like a specific rule that you can write it.
yeah.
So yeah, but I have no problem to share this.
Okay. So if it gets there, then I will also put the link to that under the video if it's being uploaded somewhere.
Okay,
So thank you very much to
thank
you
you very
to
much.
doing it and explaining it, and thank everyone for watching the video. And please remember, now it's a YouTube video, so remember to like it and to follow the channel.
Yeah,
So thank you and bye bye.
Okay, thank you very much.